work actually was funded by FDOT. I think it was through HNTV.
Okay.
To my understanding.
Yeah.
So I'm from the unmanned systems section, and Eric and John, they're in the cooperative systems section. So they've done a lot of the work with FDOT, and so they asked us or our group to kind of support them on this project. And so the idea was is that I'm sure you guys are familiar with the RCI.
Yes.
Yep. And so John, we wanted to see how can we leverage the sensor technology that's on autonomous ground vehicles or cooperative vehicles that may have cameras to populate the data in that RCI list.
Okay.
And so John actually looked through the list, and I believe there's over 300 items kind of in there.
Yep.
And he was able to kind of down select and say maybe about 100 or so he believes can be done with the technology, the sensor technology on automated vehicles.
Okay.
And so this demo is kind of a proof of concept to show if we had, something as simple as cameras and GPS, which is pretty much all that's in the box, what type of things can we do? And so on that list, we picked the lane lines or the lane characteristics.
Okay.
And so we're trying to show the ability to detect the lane lines, but not only detect them, but abstract that out to determine the lane width, as well as how many lanes there are on the road. And so for our automated ground vehicles, we use the lane lines to navigate, to help the vehicle know how to stay in the lanes. But now it's another layer of, we can use that to do additional stuff, like determining additional characteristics. And so what I'm showing here is the lane line detection. So as it pops up, it's trying to fit those lane lines to essentially a model of a highway lane. So a highway lane, you're going a lot faster, so in many cases the lane lines are more parallel. You don't have the curves where we saw, as we drove in the parking lot or coming out of the parking lot.
Connects the dots faster?
Yeah, it connects a little bit faster. And then you can see additional lanes pop up. So right now it's configured that once it sees the center lane, it looks for the left and right, and if it finds at least one edge, it will populate it up. Yeah, and so now it's detecting all of these lanes, and constantly adjusting the width. On the right image, you see the GPS. So the GPS is allowing us to track our position in the world, and so every frame we track the lane, we can actually associate a GPS coordinate to that. At a higher level, now you have all this information. Let's say if your characteristic resolution is every mile, you can essentially aggregate all of those detections up, within a mile stretch, and then kind of average them out and figure out, okay, where actual lanes are, the lane width. Because right now, because the camera resolution and field of view, we can only detect about 3 lanes. So if we go wider than that, it becomes distorted, a little bit more challenging. And so the next step of what we're trying to do is, now that we have an idea of where the lanes are, we can track that over a range and add, I'm familiar with artificial intelligence. Now that's like the big thing in autonomous driving. We can add in a small kind of AI network to classify what type of lane it is. So the next step is we want to say, okay, this is a through lane, this is an auxiliary lane, where you have the turns and things like that. And now you can actually label that, in some hierarchy map of the actual lanes that you see. And then that could feed out to here where you have a median. You can kind of say, well, this is not a lane, this is a median. And so you can kind of do all that with the classification aspect of it.
How's the RCI collected right now? The data.
I was understanding it's still mostly a manual process.
Well, I know they the video log too, right? Do they use the video log and they manually do it that way?
Both.
Okay.
So a lot of the features are put in manually. That's what's put in.
Right.
Mm-hmm.
It's like lane width from this section to this section.
Mm-hmm.
Striping width this section to this section. That's put in all manually.
Mm-hmm.
Guardrail length, all that's put in. That's all manually put in.
Mm-hmm.
This is a much lower cost way to do this than, I guess, maybe in Colorado. Somebody's doing a demo with LiDAR and trying to see, can I get curve? Can I get guardrail? Can I get guardrail entry by type? Knowing what the recognition is. But still, just to start with the basis of this is striping and lane widths.
Right.
To make sure that's accurate.
Right.
And it would be easier to update once you did a job.
Right.
You know,
Redo it.
Yeah, you could have done a lane reduction project or done a wider bicycle lane now or something like that. And now the car drives it. Could be the same car that's doing the pavement analysis vehicle, picking up all this other data.
Correct.
Could pick up this at the same time.
Right. Yeah. So we talked some more about the pavement analysis.
Yeah.